Hello and welcome back to another Orange Coast College Mathematics video. In this video we're going to talk about piecewise functions. What are they and how do I graph them? A piecewise function is really just a function that we're splitting up its domain into multiple different parts. And for each of those different parts we're going to have a different rule that we have to follow. For example, if we look at number 1, we're going to split our domain up at 0. On the number line we're going to split it up at 0. So, I follow the rule that my y value is equal to x minus 1 when I'm using x values that are less than 0. As soon as I step over into the other side, I'm now going to use a different rule, and that rule is going to be y equals x plus 1. So piecewise functions are like different states or different countries. There are different laws from country to country or state to state, and if you're in one state, or in this case, a particular section of the domain, you have to follow a certain rule. So let's actually plug in some points to get an idea of what's happening. So part A, I want to find f of negative 2. Well, I know that negative 2 is less than 0. So that means I'm going to follow the first rule, or the rule that's on top. And that's saying that my y value, my function value, is going to be equal to x minus 1. So f of negative 2 is going to be equal to negative 2 minus 1, which is equal to negative 3. Now let's look at f of 3. Now we know that 3 is greater than or equal to 0, so we're going to use the bottom rule of x plus 1. So f of 3 is going to be equal to 3 plus 1, which is going to be equal to 4. Now the tricky part comes in with 0, because we're splitting our domain up at 0. So which rule are we going to use? Well, that particular case is actually taken care of in our bottom rule because we're using a greater than or equal to symbol. So 0 is greater than or equal to 0. It sounds kind of weird, it's a little wonky, but it's technically a true statement because 0 is greater than or equal to 0. So it'll follow our bottom rule of x plus 1. So f of 0 is going to be equal to 0 plus 1, which is equal to 1. Now I want to sketch the graph of my piecewise function. First off, let's go ahead and graph the points that we just found to give us an idea of what our graph might look like. In part A, we found that f of negative 2 is equal to negative 3, so that is a point negative 2, negative 3. In part B, we found the point 3, 4. And then finally in part C, we found the point 0, 1. So let's go ahead and graph these points. So 0, 1 will be right here. 3, 4 will be up here. And then negative 2, negative 3 is down here. Whoops. This point should be over here. Now remember, our domain is split up at 0. So I'm going to put an imaginary line there in purple. And I'm going to split up my graph. So to the left of this line, I'm only working with the rule that y is equal to x minus 1. So everything to the left, we have y is equal to x minus 1. And everything to the right, we have the rule that y is equal to x plus 1. What exactly is x minus 1 and x plus 1? Well, they're both lines. Y equals x minus 1 is a line with slope equal to 1 and a y-intercept at negative 1. And then what is x plus 1? That's also a line and it has a slope of 1 and a y-intercept at positive 1. So I can draw these on their respective sides. So let's start with the blue. So I know that its y-intercept is at 1. So I'm going to start here. And as we can see, it actually crosses through both of those points that we marked out earlier. Now to make our red line, well, I know it has a y-intercept at -1, so I can start right there. However, we need to be careful because I'm not actually going to be including this endpoint because I'm working with a less than symbol. I'm not working with less than or equal to. So I need to make sure I draw an open circle at that y-intercept. Then I can draw my line. And that is the graph of our piecewise function. So let's move on down to the next one. Okay, so we have another piecewise function, except this time we're not actually splitting it at 0, we're going to split it at 1. So let's go ahead and draw an imaginary line at 1. This is where our domain kind of changes rules. Now to the left of 1, we have the rule that y is equal to +1. So to the left, we have y equals 1. To the right of it, we have the rule that y is equal to 2x minus 1. So starting with the red, when I'm looking at x values, to the left of 1, my y value is going to be equal to 1. So it turns out for all of the x values to the left of 1, I'm always going to have a y value of 1. So we could even plot a couple of those points. If I plug in -5, my y value is going to be 1. If I plug in -3, my y value is going to be 1. If I plug in -1, my y value is going to be 1. And so this is just a horizontal line. I can go ahead and sketch that in right now. However, we need to be careful. We have a less than symbol. So we're not including x equals 1 in this. So we have to draw an open circle at the end of our line. Now we can look at what's happening on the right side. We have y equals 2x minus 1. What is y equals 2x minus 1? Well, this is a line, and it has a slope of 2, and it has a y-intercept at -1. However, a y-intercept is the point on the y-axis, so it would be to the left of our line, so it might not be that useful. However, we can plug in any point we want to the right of 1 to get an idea of where to start our function. Since we're including 1 in the domain on the right side, let's just use 1. So, g of 1 is going to be equal to 2 times 1 minus 1, which is going to be equal to 1. So, when I plug 1 into my function, I get a y value of 1. And conveniently, our functions actually match up. So, I can draw a closed circle right here. And now I draw my line with slope 2. And that's the graph of our piecewise function. Moving on to our last problem, we are splitting our domain up at 0. So I'm going to go ahead and draw another line to split up our domain. To the left of it, we're going to follow the rule that y is equal to x squared. And to the right of it, we're going to follow the rule that y is equal to 1 minus x. However, I'm going to rewrite it a little bit differently. I'm going to write it as -x plus 1. So, looking at the left side of our graph, we have y is equal to x squared. Now what is y equals x squared? Well, that's a parabola. I'm going to go ahead and start graphing that. Now I'm not going to include 0, so I'm going to make sure I put an open circle. -1 squared is 1. And -2 squared is 4. So I can use that to help sketch out my graph. And now I can look at the right side. The right side is y equals -x plus 1. Now, what is negative x plus 1? It's a line with slope negative 1, and it has a y-intercept of 1. So we can graph that. Now we are including 0 in this part of the domain, so we can use a closed circle. And now we just draw our line with slope negative 1. And that is the graph of our piecewise function. That'll be all for this video, and I hope to see you in the next one.